On the morning of July 14, 1944, Royal Engineer Harold Beaumont knelt in a flooded ditch 3 miles south of Caen, mixing clay with diesel fuel. 32 years old, civil engineer before the war, zero combat experience with improvised weapons. The British Second Army had been fighting in Normandy for 5 weeks, and in the past 72 hours, German Panther tanks had destroyed 18 Churchill tanks from the 7th Armored Division. Beaumont's commanding officer had called his idea pointless. The other engineers called it messy science. When he had proposed the mud mixture concept at a briefing in Portsmouth 2 weeks before D-Day, the ordnance officer wanted to know if this was meant for training or actual combat. Beaumont explained it was for the Panthers. They shipped out before he could test it. Beaumont spent the invasion watching other men clear mines while his own experimental materials sat in a supply depot in England. He requested them forwarded through military channels. 3 weeks later, in early July, a supply sergeant handed him a wooden crate marked experimental materials. Inside were the chemicals he had requisitioned using his own civilian connections. The mixture weighed 9 pounds per container. The clay came from Norman farmland. The fuel oil came from British motor pools. Beaumont's concept was simple in theory, but untested in practice. Launch the mixture at German tank vision blocks and optics. The sticky compound would seal the glass and blind the crew. No penetration needed, no armor damage required, just temporary blindness that would force the tanks to halt or withdraw. Captain Morrison ordered him to forget the mud bombs and focus on bridge repairs. Beaumont worked on them anyway. The 7th Armored Division had been fighting near Caen since June 6th. The Germans had held the city. They had counterattacked repeatedly, but they had not stopped the British advance. They had, however, made that advance extremely costly. The Panther tanks were the problem: 5-inch frontal armor, 75mm gun, excellent optics. The Churchill tanks the British were using had decent armor but inferior guns and limited ability to penetrate Panther frontal plates at combat ranges. British tank crews were dying because they could not effectively engage Panthers from the front. The hedgerow country around Caen was different from open tank terrain. Narrow lanes, high earthen walls topped with dense vegetation, limited visibility, perfect ambush country. The Panthers would position themselves at lane intersections and wait. When British tanks advanced down the narrow lanes, the Panthers would fire from concealed positions at close range. The British tanks had no room to maneuver and no ability to flank. They died in the lanes. On July 12th, a Panther Platoon destroyed 5 Churchill tanks in 18 minutes. All 5 were hit from frontal aspect at ranges under 200 yards. The British tank crews never had a chance to return effective fire. The battalion commander summoned Beaumont that night. The Panthers were killing his tanks faster than replacement crews could be trained. He needed something, anything, that could neutralize those tanks without requiring frontal penetration. He wanted to know if that experimental mud mixture could actually work. Beaumont explained his theory. The Panther's vision system relied on periscopes and vision blocks, small armored glass ports that allowed the crew to see outside while remaining protected. If those ports were covered with an opaque material, the crew would be blind. They would have to button up completely or risk opening hatches to see. Either option created vulnerability. Blind tanks could not fight effectively. Exposed crews could be engaged by infantry. The commander gave him until morning to prove it. Beaumont spent the night preparing his materials. The clay had to be the right consistency. Too thin and it would not stick. Too thick and it would not spread across the glass. The fuel oil was the bonding agent. It made the clay sticky and difficult to remove. He mixed batches in a metal drum, testing consistency by throwing handfuls against a sheet of armored glass salvaged from a destroyed German vehicle. After 6 hours of adjustments, he achieved the right mixture. It stuck to vertical glass and remained opaque even after several minutes. At dawn, on July the 13th, Beaumont demonstrated his concept to Captain Morrison and 2 other engineer officers. They set up a test using vision blocks from a knocked-out Panther that had been recovered 3 days earlier. Beaumont loaded his mud mixture into improvised containers, essentially modified mortar shells with the explosive charges removed. The containers were launched using a standard 2-inch mortar from a range of 60 yards. The first shot missed. The trajectory was too high. The second shot hit the hull, but below the vision blocks. The third shot struck directly on the commander's periscope. The mud mixture spread across the glass and sealed it completely. The officers examined the result. The vision block was unusable. The mixture had hardened slightly in contact with air and could not be wiped away easily. It would require solvents or manual scraping to remove, neither of which could be done while under fire. Morrison approved limited field testing. Beaumont was authorized to prepare 12 mud bombs and accompany an infantry patrol into hedgerow country south of Caen. The mission was reconnaissance, not tank hunting, but if they encountered Panthers, Beaumont would have his chance. On July 14th at 06:15, Beaumont moved forward with 2 sections from the Royal Norfolk Regiment, 18 men total, 3 Bren guns, 1 2-inch mortar, and Beaumont's 12 mud bombs packed in canvas bags. The patrol moved south along a sunken lane toward a crossroads the British called Junction 7. Intelligence reported Panthers operating in that area. The hedgerows were 8 feet tall, earthen walls with centuries of root growth creating natural fortifications. The lanes between them were barely wide enough for a single tank. Visibility was limited to 50 yards in most places. The patrol moved carefully, watching for German infantry, listening for engine sounds. At 08:43, they heard it. The distinctive rumble of a Maybach engine. Heavy, deep, unmistakable. Panthers, multiple vehicles, moving slowly through the hedgerows. The patrol took cover in a drainage ditch and waited. Beaumont set up the 2-inch mortar on level ground and prepared his first mud bomb. At 09:07, the first Panther appeared at the crossroads. The tank was moving east, turret traversed to the right, watching the southern approach. The commander's hatch was closed. The tank was buttoned up. Beaumont estimated the range at 70 yards, close enough. He loaded the mud bomb into the mortar and adjusted the elevation. The infantry sergeant whispered that this was insane, that Beaumont was going to get them all killed by attracting a Panther's attention. Beaumont fired anyway. The mortar made a soft thump. The mud bomb arced through the air and struck the Panther's turret front, directly over the gunner's sight. The mixture exploded on impact, not with explosive force, but with the kinetic energy of impact. Sticky brown mud spread across the gunner's optics and the commander's periscope. Both vision ports were sealed. The Panther stopped moving. The turret traversed left and right, searching. The crew could not see what had hit them. Beaumont loaded a second mud bomb and fired at the tank's driver vision port. Direct hit. The front vision block disappeared under brown mud. The Panther was now completely blind from the front. The German crew reacted. The commander's hatch opened. A German tank commander appeared, looking for the source of the attack. The British infantry sergeant shot him with a rifle. The commander dropped back into the turret. The hatch closed. The Panther began backing up, trying to withdraw while blind. Beaumont heard the second Panther before he saw it. Another Maybach engine, approaching from the south. The patrol was now between 2 Panthers in a narrow lane, with no room to maneuver. The sergeant ordered his men to prepare to withdraw, but Beaumont was already loading another mud bomb. The second Panther appeared at 90 yards, moving slowly, turret scanning. Beaumont elevated the mortar and fired. The mud bomb struck the turret side and partially covered the commander's vision port. Not a perfect hit, but enough to obstruct vision. Beaumont reloaded and fired again. This shot hit the driver's vision block dead center. The second Panther stopped. Both Panthers were now immobile in the lane, blind, unable to advance or effectively retreat without risking collision with hedgerows or each other. The German crews had 3 options: open hatches and expose themselves to infantry fire, attempt to drive blind and risk getting stuck, or wait for supporting infantry to clear the area. They chose to wait. The British patrol withdrew. They had accomplished nothing except blinding 2 Panthers, but that was enough. The tanks remained immobile for 27 minutes before German infantry arrived to provide security. During those 27 minutes, a British anti-tank gun team repositioned to cover the crossroads. When the Panthers finally began moving again, the anti-tank gun engaged from a flanking position. Both Panthers were destroyed. Word spread through the Second Army that afternoon. Engineers had discovered a method to blind German tanks using mud bombs. The concept was crude, makeshift, but it worked. Captain Morrison filed a report with division headquarters. Beaumont was ordered to prepare a detailed technical description of the mixture and the delivery method. By July 16th, Beaumont had trained 6 other engineer teams in mud bomb preparation. The mixture recipe was standardized: clay from Norman soil, diesel fuel at a ratio of 3 parts clay to 1 part fuel, mixed to a thick paste consistency. The bombs were packed in modified mortar shells or thrown by hand if the range was close enough. Optimal engagement range was 50 to 100 yards. The engineers used the mud bombs in 12 separate engagements over the next 2 weeks. The results were mixed. The bombs worked best against stationary or slow-moving tanks in confined terrain. Against Panthers moving at speed in open ground, the accuracy was poor. The 2-inch mortar was not designed for precision fire, and the mud bombs had irregular ballistic properties. But in hedgerow country, where tanks moved slowly through narrow lanes, the mud bombs proved effective. British infantry learned to coordinate with engineer teams, pin the Panthers in place with the mud bombs, then maneuver anti-tank guns or Piat teams into flanking positions. The tanks could not effectively respond while blind. German tank crews adapted. They began moving with infantry support in closer proximity. They stationed men on the hull to watch for mud bombs and provide warning. Some crews welded additional vision blocks onto their tanks, creating redundant optics that could not all be covered by a single bomb. The effectiveness of Beaumont's invention decreased as the Germans learned to counter it. By August, the British breakout from Normandy had begun. The fighting moved into open country where tank warfare was more fluid and mud bombs were less practical. Beaumont's concept faded from use, replaced by more conventional anti-tank methods. The engineers returned to bridge building and mine clearing, but the idea did not disappear completely. After the war, military researchers studied Beaumont's mud bombs as part of broader research into obscurant materials and methods to disable armored vehicles without penetration. The concept of blinding enemy optics rather than destroying enemy armor influenced the development of smoke generators, vision-blocking compounds, and eventually laser blinding systems. Harold Beaumont survived the war. He returned to England in 1945 and resumed his career as a civil engineer. He worked on post-war reconstruction projects, rebuilt bridges, designed water treatment facilities. He never spoke publicly about the mud bombs. The concept was too improvised, too crude, too far removed from proper engineering to discuss in professional circles. Beaumont died on March 9, 1987. He was 75 years old. His wartime notebooks were donated to the Imperial War Museum. They contained detailed sketches of the mud bomb design, mixture ratios, trajectory calculations. Most visitors to the museum never see them. They are stored in archives, available to researchers but not displayed publicly. The mud bombs were never officially adopted by the British Army. They were too situational, too dependent on specific terrain and tactical conditions. But for 2 weeks in July 1944, they gave British infantry a way to neutralize German Panthers without requiring armor penetration. They changed the tactical dynamic in hedgerow country. They saved lives. If you found this story interesting, hit that like button. Every like helps share these forgotten pieces of history. Subscribe and turn on notifications. We are bringing you real stories about real soldiers who improvised and adapted under impossible conditions. Drop a comment and tell us where you are watching from. Are you from the United Kingdom, United States, Canada, or somewhere else? Our audience is global, and you are part of keeping these memories alive. Thank you for watching, and thank you for making sure Harold Beaumont and his crude, sticky invention are not forgotten.